All right, now the whole reason that we even use these rational exponents is because it allows us to simplify things that don't have like radicals that don't have the same index. Okay, it allows us to simplify things like this. For example, this is the square root of 3 and this is the cube root of 3. They're not the same. We can't combine them together and multiply them or do anything with them unless we turn both of these into rational exponents. If I rewrite radical 3 as the square, or 3 to the 1/2 power, and if I rewrite the cube root of 3 as 3 to the 1/3 power, now I can use what I know about properties of exponents and also what I know about rational numbers to simplify this. If you have two bases that are the same, you simply add the exponents. We did that last lesson. Now, to be able to add these exponents, I need to have common denominator since we're dealing with fractions here. So let's rewrite 1/2 and 1/3 so that they have a common denominator of 6. Okay? So this would be, I'm going to come down here. This would be 3 to the 3/6. That'd be 1/2. So 3/6. And then 1/3 would be 2/6. Multiply both these by 2. Plus 2/6, which is going to give me 3 to the 5/6. Okay, so I've simplified these two radicals into one. And I could rewrite this as a radical. So again, it'd be 3 to the 5th, and then it'd be the 6th root of that. So the 6th root of 3 to the 5th. And you can put the 3 to the 5th inside the radical. You could put the 5 on the outside of the radical. Doesn't matter, they're the same thing. Okay? But that's why this rational exponent thing is kind of helpful to us. Like the next example. There's no way to simplify this. There's no way to cancel, reduce, or do anything with this unless we think of x as x to the first, and we think of the square root of x as x to the 1/2 power. Now we can use the properties of exponents that says, oh, well, if you're dividing the same base, then you just subtract the exponent. Well, 1 minus 1/2 is 1/2. So this simplifies into x to the 1/2 power, or just the square root of x, which we wouldn't have known unless we could go off to the side and think of these as actual numbers that we could, play with. We can add, we can subtract, do things like that. Okay, look at the next example. So what do I have here? I have the 6th root of 9 times the cube root of 9. So the number in the radical is the same, but these indices are not. So to be able to simplify this, I'm going to rewrite this as 9 to the 1/6 times 9 to the 1/3. All right, so what do we got here? We've got two rational exponents. I could rewrite both of these so they have a power, so they have a base of 6. So I'm going to leave 9 to the 1/6. And then I'm going to rewrite 1/3 as 2/6. I'm going to multiply both these by 2. 9 to the 2/6, which means now I can add these together. 1/6 and 2/6 is 3/6. But hold on. 3 over 6 is 1/2. But hold on. 9 to the 1/2 power means the square root of 9. And so we get 3. So that is the answer, the simplified answer to that expression, which we wouldn't have known until we converted things into rational exponents. Okay? All right. Last example before you guys try. All right. So let's rewrite this as 7 to the 3/4. We're going to rewrite this as 7 to the 1/2. We're going to say, oh, we're multiplying the same base, so I just need to add these exponents together. But before I can do that, I need to rewrite this one so it has a common denominator of 2/4. Now I can add these together. I can say 7 to the, 3/4 and 2/4 is going to be 5/4. which, now, if you have, and this would be an improper fraction, right? So this is like 7 and to the 1 1/4 power. Okay, so if you think of it that way, and honestly, I'm okay with this answer. You've done what I've asked you to do. But this can be simplified. This is really, if you have 7 to the 1 1/4 power, 7 to the first power means you have a 7. But then you also have a 7 to the 1/4 power, which means you have the 4th root of 7. So this is a simplified version. Again, if you wrote this, I'm not going to be upset with you right now. If you turned this into a radical and said, oh, it's the 4th root of 7 to the 5th power, I'm not going to be mad at you right now. But technically, this is the simplified version of that. You would write it that way. Okay? So take a look at the examples on the bottom and let me know if you've got any questions.